Very good morning, one and all gathered here. Today we are going to have some of the basic concepts of thermodynamics. So this is going to be the today's agenda. Let us go with the important concepts of thermodynamics and what is meant by a thermodynamic system. What are the various properties of thermodynamics followed by thermodynamic various process. Before moving to the main theme of the presentation, let us understand the classical meaning. What do you mean by thermodynamics? So the term thermodynamics can be splitted into two separate entities. So thermo means heat addition. Dynamics means motion. So here the field, the thermodynamics, on the microscopic point of view, we can able to analyze the heat movement within a system. So thermodynamics is a branch of physics that deals with the amount of energy produced and also the work done by the given system. But however, the thermodynamics can be specifically explained in such a way by narrating the flow of heat transfer, how it has been converted from one form of an energy into another form as per the first law of thermodynamics. It is energy cannot be destroyed or nor be created, but we can able to convert into one form of an energy into another form. This is the first law of thermodynamics. So without affecting the state of the process, we can do the energy conversion from one kind to another kind of process, another kind of energy. So the source of thermal energy comes from the heat, and this heat generated is due to the movement of the tiny particles. You take the gas molecules. When two gas molecules are colliding with each other inside a closed container, so it makes the particle to move faster in randomness. So it releases more amount of heat. So consider this example: the energy transfer from the hot body to the cold body, and it is not necessary that all 100% energy is used for utilizing the useful work. Only 20 to 30 percentage of the work will be done by the system, and remaining 70 percentage will go as a heat rejection, as a waste out of the system. So the term thermodynamics is not exactly concerned about how and at what rate the energy transformations are going to be done. It is based on the two state of the process, initial and final state of the process, which undergoes a change. And there are two different signs in thermodynamics. One is microscopic and the other one is macroscopic thermodynamic system. Macroscopic thermodynamic system deals with the change process happening within a bulk system, say volume, temperature, pressure, etc., enthalpy, entropy. There is a microscopic thermodynamics that deals with the smaller scale, say molecular fraction of a gas molecule within a closed system. So studying the behavior of the gas molecule within a closed container, that tells about the microscopic aspects of thermodynamics. Now let us go with one of the most important, the basic parameter in thermodynamic science. What is meant by a system surrounding and a boundary? A system is nothing but any mechanical equipments. Say, for example, you can take a heat engine, internal combustion engine. So that is considered to be a system. So the system is isolated from its surroundings. Whichever the surrounding part which is kept very close to the system, they are called as the surroundings. And the boundary is an imaginary separation layer between the system and surroundings. So let us discuss in more detail. A system is nothing but a region which has some useful amount of energy to be carried out. So the system will do the energy conversion process with respect to a given state of matter. And this system is being separated away from the surroundings by imaginary wall barrier we call as a boundary. In thermodynamics science, a system is considered to be the most important subject for detailed analysis. Other things which is kept out of the system is the surrounding, or we can say universe. Now let us go with the thermodynamic different types of system in thermodynamics. So closed system. So here energy can be transferred within a system, but the matter cannot be exchanged. Mass transfer is zero, but the heat transfer can be quickly done within the environment. Say, for example, you take a tea cup tightly closed with a cap or lid at the top of the teacup. So, if you close a lid over the uh, cup which has a tea or a coffee, so inside within the closed medium, so heat may get transferred, but mass may not get easily transferred because the surface is tightly packed closed with a lid. But in open system, both heat transfer and mass flow can be made possible to interact within the from system to surrounding, say environment. You take the same example, consider a cup of coffee said to be open at the top without closing the lid over the top of the cup. So under room temperature, both heat and mass transfer can happen very easily in a in an open system. Isolated system. So here there won't be mass energy. Both mass and energy will not transfer very easily with the surroundings. Say for example, you take a thermoflask. So the thermoflask has an insulated material inside the medium. So if you store a hot water inside the thermoflask, so heat will be contained constant forever, and the mass of the water that will also maintain constant. So there is no exchange of matter or energy with respect to the outside environment. So these are the three different types of thermodynamic system. And coming to the basic properties of thermodynamics. So intensive property and extensive property. So what is meant by extensive property? So you take a thermodynamic system that is purely depend on the mass or size of the system. You take volume, pressure, temperature, enthalpy. These are the thermodynamic variable which comes under extensive property. Intensive property, so any system that is independent, which does not based on the mass or size of the system, purely independent in nature. You take boiling point, freezing point, specific heat density. These are the thermodynamic variable fitted under intensive property. So to explain this, let us have an example. Consider a classroom which, which has 50 students. The overall strength of the classroom is 50 number of students. Okay, so let us define the thermodynamic variable for the classroom. So temperature, pressure, volume, and concentration. Right. So here we want to define what are the intensive properties and extensive properties. So in the next figure, the classroom has been partitioned into two rows within a given area, surface area. So the classroom has been divided into two separate partitions. Okay, right? So now here, with whatever the variable which is going to change the system, that will be recorded here in the right side of the region, and the remaining variable which is does not going to affect the size or the mass of the system, that will be recorded in the left side region of the area. So you take temperature. So temperature is a intensive or extensive property. So what is a extensive property? So the thermodynamic system which purely depends upon the mass as well as the size of the system. So here volume. See, by dividing the classroom into two separate partition, I'm changing the space, the volume occupied by the classroom. So volume is a extensive property. So that will change. Whereas the other remaining concentration, temperature, pressure, that will be remain constant. Okay. So this is one simple example how to define what intensive and extensive property just by taking a classroom as an example. Now let us see what are the different type of process, thermodynamic process, isothermal process. Here the temperature is maintained constant throughout the state of the system, both initial and final state. But there is some amount of energy transfer takes place, but the temperature is maintained constant. The volume may get changed, pressure may get changed, but this parameter, the temperature is retained as an equilibrium condition. So we used to call this so-called process as isothermal process. Next one, constant pressure process, isobaric process. Same like isothermal, but instead of temperature here, only pressure will be maintained a constant, whereas the other parameters will subjected to change with respect to the system. The third classification, isochoric process, constant volume process. So instead of pressure, temperature, the volume will be maintained constant by varying the pressure. So we call as a constant volume process or isochoric process. So it is shown from the evidence from the PV diagram. The next one is a reversible process. So here there are two classical examples. So you take any thermodynamic system which can be easily reversed. We can able to regain the original state of the system from the final state. So such a thermodynamic process, we call it as a reversible process. Say for example, you take a chocolate a dairy confectionery item. So it is normally stored under the cold storage place within the refrigeration process, cold storage. By the time it will be very hard, solid structure. Now, if you take the chocolate from the cold storage and keep it in a open medium, so the solid matter will be converted into a liquid matter. So two different change of phase. If I want to again bring back to the original state from liquid to solid matter, again I can keep that the chocolate which is available in liquid substance, again bringing back to the cold storage device. So it will begin to undergo recrystallization and it will be treated as a solid matter. So here the exchange of energy takes place between both initial and final state. So we can able to regain the same shape from the final state. But here in irreversible process, it is not like that. You take an example of a white egg. So I want to make an omelette from the egg. Earlier, it is like a white shell, a strong white shell which has a yellow matter inside the white shell before breaking. So this is the initial state of the egg structure. Then after breaking the egg into two fragments, so I'm going to pour that yellow matter on the hot pan to make an omelette. So we cannot able to regain again back to the original initial state. It is not possible. Next one is adiabatic process. Here, heat will be maintained constant, but volume, temperature, pressure may get vary. But we have to focus on the constant heat. So heat rejection is zero. There is no heat addition or heat rejection. So Q is equal to zero in this state in adiabatic process. So in this webinar lecture, we have seen the most important basics of thermodynamics and different thermodynamic variable along with various nomenclature. So in the next webinar, we will see some of the remaining topics that is present in the basics of thermodynamics. So thank you for your kind, the patience listening. Thank you, one and all.